that blob.
Oh, you caught me. I'm in the hallways of Harvard and working on a very complex math problem. Oh, I must be very smart.
You need therapy from Robin Williams.
Yeah, but I'm gonna reject him at first and be mean to him about his passed away wife.
Those are your defenses from your rough childhood.
Right, but it's not my fault.
It's not your fault. Hey, it's not your fault.
Stop it.
Don't you know
Stop it.
that it's not your fault?
Stop. Oh!
Do you get it now?
Yes, all my problems are fixed.
That's all that it takes.
Then you make a movie about it. That was actually their relationship in real life at the time.
No way.
Oh no.
You know, I didn't realize that it was about a guy named Will Hunting. I thought it was like, hey, you're gonna go hunting? Here's Goodwill. I didn't know. I just didn't know.
You just didn't know. It's not your fault.
There is no way for me to know. Don't you see that?
I see that. I also see that every time you exhale, the breath goes out the eyeball holes of that mask and fogs up your glasses.
Well,
I really hope they can see it, but unlikely.
That's how lions work.
Oh, they breathe out of their eye holes?
Yeah, did you not know that?
I didn't know that, but it's not my fault.
What do you think about the two of us doing a sick dance break?
I feel pretty good. 1, 2, 3, go!
You've got to do better than that, Mr. Levi. Are you okay?
I'm okay, but my marker's not.
You're ruining the dance break. 7:30 to 9 p.m. Eastern Standard Time.
1, 2, 3, let's go.
Willkommen. Welcome to the stream. This is my associate.
I'm the partner.
Yeah, he's my partner.
We're going to talk about the mathematics of the body.
The body.
The body's mathematics, yeah.
Oh.
Yeah, 5 fingers plus 5 fingers equals jazz hands, you know?
I did not know that factoid.
Yeah, these German doctor coats
Quotes.
smell like boxes.
Do they?
Yeah,
That's because they came out
they
of
smell
one.
like musty basement boxes.
That's where German medical coats are made. You don't know that?
Oh, in the musty basement
Part
boxes?
of the process of making a German
Oh,
lab coat is you
that's
need a
nice.
musty basement.
Oh,
it's
that
1
makes
part
sense.
musty basement, 2 parts humidity, and 3 part German potato soup.
That's good.
As long as you sound a little Irish. Anyway, here we are. We are here for your viewing pleasure. Very, very pleasurable viewing.
Yeah, viewers pleasurably. No, you're not. Hey, would you like to ask us some questions?
Where's your stethoscope?
Over there.
Yeah, it is over there. How will you check the heart rate of someone like me without your stethoscope?
What is it supposed to be? Are you going to suck up the heart?
Libertad, you're following us. Thank you. We will follow you back. Here for the lobotomy. I will give you a lobotomy if you give me a lobotomy.
I don't like lobotomies.
What about phlebotomies?
Maybe.
What about phlegmbotomies?
That sounds nicer.
What about fembots?
Fembots.
Yeah, Austin Powers.
Like Felicity was a fembot.
She was a fembot the whole time. Anyway.
This is strange.
Yeah, it was very cheap. Chemist.
Chemist,
Good
evening to you.
Yeah, guten Tag.
We're going to make a chemistry soup today. We're going to, make it out of mathematics.
Heat up some water.
Yeah.
Wasser? Water.
I don't know.
Yeah, I don't know either.
I think it's pronounced water.
I think you're
Okay.
right.
I think here in the moment, do you have any questions for us?
Here in the moment has a question right there.
72C in the mass. All rise.
I want to do this question.
You don't know how.
Yes, I do. Can I do this question?
No, you can't.
Why?
Because you're only in your 2nd year of medical school.
Oh, I'm going to sue you.
Why?
Because you pushed me against the wall.
The Germans don't sue.
Here in the moment, can I ask for advice on college apps? Yeah.
we might not be able to give it, but yes, of course.
prefer that you don't.
We love college app questions. It's not our main source of nutrition, but it'll do.
It'll do.
It'll do.
Okay, here in the moment, it's coming, don't worry. 27 in the mass here. Okay.
My stethoscope is sticking out of my lab coat. I will place it in here. Is it better to apply with a weaker application or apply regular decision with a stronger application?
Why don't you look up the differences in the acceptance rates at the different times of applications, and then make a judgment call? Or tell us now, and then we will talk about that.
That is a very good point, Levi. Sometimes it is easier to get in when it is early, and sometimes it is easier to get in when it's regular. I feel like it's probably easier to get in early. The percentages of acceptance are probably higher, maybe?
Yeah, that's true, but maybe it's not very much, and then don't.
Saying applying early has no advantage. In that case, do not apply early. Apply when you have a stronger application.
Yeah.
I feel like that's their way to go.
Yeah, if they say that, then let's do that.
27. What is the perimeter in inches of the isosceles right triangle shown below, whose hypotenuse is 8√2 inches long? Okay. So, we have an isosceles right triangle.
May I draw it?
Yes, you may draw it.
I feel like one of us should talk normally.
Well, one of us should be like Dr. Nerd. Maybe the other one's Dr.-ish. What do you think about that?
I think that's good.
So, Levi's triangle is not very isosceles, but it's supposed to be isosceles. How did you know that that side was going to be the hypotenuse?
Whose hypotenuse is 8√2.
Whose hypotenuse? Your hypotenuse.
Yeah.
Yeah, but how did you know it was going to be this side?
Well, why don't you break down the word hypotenuse?
Yeah, I think I will.
Hypo meaning
under.
And tenuse?
Tenuse means right angle. So we are under the tenuse, right here.
Yeah.
We don't know exactly what tenuse means, but they did used to draw it like this, with the hypotenuse on the bottom and the right angle up top. You can see it.
No, it's not.
Yes, it is. This is a special right triangle.
Your special right
It's
triangle.
isosceles, so these two sides are the same, which means that these two angles are the same. There's only one way these two angles could be the same, which is that they are both 45, because they must add up to 90.
Yeah.
So this is a 45-45 right triangle. Sorry, 45-45-90 right triangle, which means the pattern is x, 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 √2. And looking at this, it looks like x simply has to be 8.
What about this x?
That also has to be 8.
But in blue, yeah?
But they want a perimeter. I don't know how to do the perimeter. I'm scared, Dr. Levi.
Okay, he's scared, and I will take over as your attending physician. So, what we do is we add all the sides up, because that's perimeter, and if you don't know that, you are out of luck.
You're cooked,
You
as
are
we say in
the business.
the business.
Our business.
Yes.
That's the answer.
It's what they said in Dresden.
Yeah, so the answer is, oh.
They were cooked. Get it?
No?
Dresden.
Who's that?
It's the city that they firebombed.
Who?
The Allies in World War II.
Oh, yeah.
The city was just a beautiful city. That
You
they
sound like
destroyed.
Alvin and the Chipmunks when you were saying yeah.
You write like Alvin and the Chipmunk when
Yeah.
you were texting that.
Yeah.
Is there a program that puts special right triangles? Yes, here in the moment. The programs that I have on our Discord, it has a list of geometric formulas at the end of it, and a couple of them are pictures of right triangles with the patterns in them.
Yeah, and for one low price of $19.92, you can buy that, and then you get a second program that is identical for free.
How about that?
Yeah. Oh, how about it?
Yeah.
Here in the moment.
Also, if this is for the ACT, yes, they don't give it to you, but on the SATs they do give it to you. But if you're taking the ACT, it's a good idea to put it in your calculator. Slayer Darth, our good friend from the UK. The UK was not very good to us in World War II.
No.
But I must say, we were not good to the UK in World War II. Some might even say that we started the war.
Nobody says that.
Some. Which program was a Discord? The first is the second link. I tried to go through the trick section in yesterday's part. We didn't get very far. So I can continue where we left off if there are no other questions from anyone. Here's a moment. The first and second link. I have to look at it. One of them, it depends on your calculator. What kind of calculator do you have? We weren't good to you guys in 1914 either.
Yeah.
9.
But it's okay.
T84 plus CEs. That's a heck of a calculator.
According to Serena Williams.
Yeah, on our Instagram. You should follow us if you haven't. We're putting out quality content.
It's very quality.
Yeah, one of the programs is for the TI-83s. The other one is for the TI-84 pluses, I believe. TI-83 and 84, and then there's the plus one. You want to pick the one that is for the plus one. I think I explained which one was for which. And then one of the links is to get the application on your computer that will let you upload the program onto your calculator. You need a cable, by the way. You're going to need a cable to connect your calculator
You
to
weren't
your
paying
computer.
attention? Then go back and look at it later.
You weren't paying attention. You did say which is which, my fault. Ha! No, it's okay. Dr. Levi.
No, Dr. Levi was my father.
Who are you?
Young Levi, doctor.
Young Levi, doctor. For a German, you seem to have spent a lot of time in America. Oh, never mind. I just confused you guys. Scratch everything I just said. All of it. I will scratch it. I will scratch what you just said.
Are you surprised we took what you said and did it that way?
Yeah.
We just misinterpreted.
We're very
things
literal,
willingly.
concrete people.
Yeah. You got that from RDB, don't you?
Little bit.
I know you did.
Don't say anything.
I know you did.
Don't say anything. Anyway, I wonder if this will come out later in life and you'll say that we are...
maybe it will, maybe it won't.
Oh man.
Do you like that? Does that turn of the vowel O?
I like that.
Yeah.
Maybe it will and maybe it won't.
Won't.
Yeah.
Okay. Well, do you have any questions? If you can answer them. It's like other streams, but they're more annoying in this one.
I'm going to take your heartbeat.
Yeah.
I-
Wait, who is the viewer?
Ooh.
Let's take the heartbeat of the triangle.
Of the triangle.
Yeah. And the heartbeat is
XX, X root 2. XX, X root 2. XX,
That's
X root 2.
literally the stupidest thing I've ever heard or
I love
seen
it.
or experienced.
I love it. That's the heartbeat of the triangle.
Okay.
It's a...
So scalene triangles have no lengths, equal lengths or angles.
9. They do not. None of them.
Well, unless they get very, very large. So when the triangle gets very large, then the triangle rules break down.
Yeah.
Because the triangle rules cannot get so large.
Yeah, the rules are limited in this size.
So if the side length exceeds 200
Light years,
then it breaks down.
Yeah. Equilateral triangles, yes. So they have 3 equal lengths and 3 equal angles. Isosceles have 2, scalene have none. That is the definition of those 3 types of triangles.
Oh, I have a question for you.
You do.
Yeah.
State your question
Show it.
after the beep. Beep.
Question.
State.
Get back to me. All right. Wait. So, are we doing here in the moments question, or no? What are we doing?
I think. Did Here in the Moment have more questions?
I don't know. Here in the moment. How are you?
Are you in the moment?
Or are you neither of those things?
Look at this. It's like a ghost.
Oh, what is a ghost heart rate?
VOD. Be right back while I watch the trick section from the VOD.
Oh. Okay.
Need to fix
Hey,
this.
Brady.
Yeah, Dr.
What do you
Levi.
think about this triangle? Okay.
Yeah.
And this is 15, and this is 12. What is the length of that leg?
Mine, Doctor. I'm looking at it right now, and I see some things that I like a lot.
Yeah.
I think this is an example of a 3, 4, 5 right triangle.
Just scaled up, you know?
A 3, 4, 5 right triangle.
Yeah.
Not a 3, 4, 5. It's a 3, 4, 5. That's how they say it in Germany.
Oh yeah, this like this. Because
Yes.
oh my God, you watched Quentin Tarantino, don't you?
Yeah, but I knew that. I didn't know that. It's from the movie. So this is scaled up.
No, no.
Oh no. Oh no. Oh. So I need a
This-
vag. I need a vag.
A vag?
A vag. Yeah.
So
Sorry.
you wag your tail.
Sorry.
You race with a rag.
So this is 5 times 3. This is 4 times 3. Therefore, I know that there's such a thing as a 3, 4, 5 triangle. And it looks like all of these side lengths have been scaled up by a factor of 3. Therefore, this will be 3 times 3.
Which is
9!
9!
9!
Is that right? You got
Ja, nein. Ja, nein. Ja, nein. Nein, ja. Nein, ja, business.
it. Yeah, that was a ride.
That was what?
A ride.
Alright.
A ride.
Alright.
A ride.
Who else has questions? We have answers.
Yeah.
Thank you for the calculator program.
Here's a moment. Explore the program, but be careful because there is one of the last things in the program puts a bunch of formulas on your screen. And if you want to get out of the program very quickly, you can always just press second off. Second quit does not work. I don't know why I did not make the program, but second off will turn your calculator off. You turn it back on, and then it's the home screen again. However, that last part of the program hijacks your calculator's grapher. So if you try to then graph something, the graph will still be on in the program. So what you have to do is open up the program again, go down to quit, and press the official quit function on the program. It's number 7 or something on the main menu. You have to quit the program from inside the program to officially quit the program. That's the one thing that
Can
might
you
happen.
not turn it off and then turn it back on?
You can do that. The problem is your grapher will still be in program
Oh, so it
mode.
does not. You have to quit it.
You have to quit it.
Okay,
Yeah.
that makes sense. Okay. Now, here in the moment, it's been... Oh! What's that?
What?
Oh!
Ooh.
How do you do this without a calc?
I like to do this one. May I
Do
do
you want
this
to do
one?
that? Could we maybe change
Good.
the numbers? Or no?
What test is this from? What test is this from?
I don't know.
Wait, go back.
Who asked this question?
Chemist?
A better nickname. Who is that? And is this question from one of the tests down there, or we can come up with another example? I will make you another example, okay?
It is from ACT A10. I don't think A10
No,
is
we can't do that.
available. Okay. I like where this is going. So, okay. Got it. Okay. Yes. Absolutely. Yeah.
Yeah.
Yeah. LOL, what? We've got a similar type of question.
Okay, so we can't do this exact question because we're not allowed to put up the other things because you haven't been here in a while, but we got knocked for doing copyrighted material and putting it on here, so we're going to have to change the question so we're not sharing copyrighted material.
Yeah.
So, okay, so it's
What kind of material?
copyrighted.
Copyrighted. Gracias.
Okay, so the first term, x cubed minus
X
plus x squared, 2x squared.
plus 2x squared.
Could you write up the other part of the question?
Yeah. Oh, yes. Okay.
Oh, I did x equals positive 1, but it doesn't matter.
That's fine. That's fine.
Okay, just be aware of that.
Yeah.
Okay.
Keep writing.
Okay, so
one solution is x equals 1. One solution is x equals 1 and is equal to 0.
Oh, we'll do it here on this side, yeah?
Yeah.
Okay, so this is similar to your question, yeah? And so, accept this. It's the same process.
For one solution is equal to x equals 1 and then The other question, or all of the answers are what kind of the other two solutions are going to be.
Okay,
So
I will write up the possibilities.
The answers, as Levi writes them,
will be both are negative real numbers. One is a negative real number and the other is a positive real number. Both are positive real numbers. One is a positive real number and the other is a complex number that is not real, and both are complex numbers that are not real.
So, what we have to figure out is, do we have real or imaginary solutions?
And are they positive or are they negative? That is the question.
Okay, so this is a cubic. A cubic will have 3 total roots because it is a cubic. If your degree is 3, then you have 3 total roots. Whatever the degree of the polynomial is the number of roots that you are going to have. However, we do not know if they are going to be real or imaginary. That is the problem with knowing there are 3 total roots. We don't know. Imaginary roots always come in pairs. So you could have 2 possibilities here. You could have 3 real roots, or you could have 1 real root and 2 complex, which is, it has imaginary in it. 2 complex roots. You cannot have 1 complex root. For instance, if 4 plus 2i is a root, 4 minus 2i will also be a root. The complex conjugate will always come in pairs. So you cannot have just 1 complex root. You need to have 2 of them. Therefore, these are the only 2 possibilities for the breakdown of your 3 total roots.
Real quick, whoever asked this question, does this question acceptably map onto the questions that you used? Who's still here?
LOL, right, yes. Yeah.
Okay,
Yeah.
good. I'm going to go sit down and do Dr. C.
Very good, very good. Do all the doctor things?
Yeah.
German doctor things, yeah. Okay, so that is what we have to figure out. If one solution is x equals 1, that means that we know a factor. We know a factor. One of the factors is going to be x, x minus 1. Yeah. LOL what? Do you understand that if one solution is x equals 1, one of the factors is going to be x minus 1? Because if this is a factor, 1 will be a solution, and that is what we have up there. Does that make sense? Yes. Very good, very good. Just a reminder of visually what's happening.
A cubic goes from here to here. So it can maybe cross once and have 1 real root, or it could cross twice. Sorry, 3 times. This is the way to get the 2 situations. This one only has 1 real root, and so this one has to have 2 complex roots. This one has 1, 2, 3. 3 different x-intercepts, 3 roots, okay?
The easiest way to do this is to put this in your graphing calculator and see what the graph ends up looking like. That is the fastest way. Y equals this whole thing. You will see where the roots are. You will see where the roots are. We don't have a calculator down here, so I do not know. I don't know exactly. Well, I can figure this out. I'll show you the long way. But when you graph this, you'll see how many real solutions there will be, and you'll be able to eliminate some options. Levi,
Yeah.
can you throw this into Des? Oh, I can put this on Desmos actually.
You don't know.
Yes, we have the internet on here. Okay. Here we go. Desmos. This is going to be, I don't know why we've never done this before. Desmos. Beautiful free math. So, I'm going to turn this on. We are now on Desmos. This is a new era. A new era for nerdish. Except this is, I'm gonna do this, okay, down, and then, whoa, there we go, okay. Y equals x to the cube, there's x cubed, no, that's x squared, x cubed, plus 2x squared, plus 2x squared, squared plus 5x, And then we have minus 8. Okay. Minus 8. Let's see what this thing looks like. Okay. So you can see from this what the graph looks like. There is only one real root. That is all we see. Therefore, we can get rid of some of the options. Both negative real roots. So asking about the other two that we do not know. No, they are not going to be real. X. One negative, one positive real root. No, 9. Both positive real roots. No, they are not real. I don't know how many times to tell you this. One positive real, one complex number. That is simply impossible. Complex solutions always come in pairs. I feel like my accent is going all over the place.
Yeah, it's kind of all over the place.
Well, I've lived all over the place because my parents are military.
It's fine.
One positive real number, one no. Two complex numbers, that has to be what it is. That has to be. Because we do not see the roots. If you do not see the roots, they are complex, they are hidden because they have an imaginary component. Now that is the graphical approach, and as you can tell, that is very quick. It's very quick. You'll also know by looking at it if the roots are positive or negative. So if this did cross 3 times, you'd be able to see where all the roots are. Now, the other way of doing this, if you do not have a graphing calculator, is with either polynomial long division or synthetic division. I will show you what that looks like. So x minus 1 is a factor. We all agree on that because we know a solution is x equals 1. So that means we should be able to take this polynomial and divide by x minus 1. There are a couple of ways of doing that. There is synthetic and there is polynomial long division. It takes a while to get the hang of them, so I will just show you very quickly. If I use synthetic, which will be faster, it was going to be 1. And I will put this here. 1 is because of that, and then we have 1, 2, 5, negative 8, which are all these numbers here. Going, where's all the markers I had? They're all gone. All of the markers are gone. I bring the 1 down. This is 1. Multiply 2. Bring this down 4. Multiply. We get 4. Multiply. We get 9. And then we have. I think I did something wrong. 1. No. 1, 2, 5, negative 8. Bring down the 1. 1 and a 2. 4. 5 plus 4 is 9. 9. Levi.
Yeah?
Are we sure that we multiplied this all correctly?
No.
X cubed plus 3x squared plus 8x. Oh, wait. 2x squared plus 5x minus 8. X cubed minus x
it should be,
squared
I don't know.
plus 3x squared minus 3x plus 8x minus 8. Okay. So the x squareds become plus 2x squared minus 3x plus 8x is plus 5x minus 8. Levi, what did I do wrong?
I don't know.
We should not have a remainder. This should multiply cleanly. 1, 2, 5, negative 8. 1. Oh, satisfy. My fault. It is my fault. 1 times 1 is 1. Therefore, this is 3. Therefore, this is 3, 8, 8, and then 0. Therefore, we have x squared plus 3x plus 8. So that is what we can put here. The squeakiness reminds me of the soup that my mother used to make in the old country. It's very squeaky soup. So now the question becomes, what are the roots of this quadratic? And if you know your discriminant properties very well, you can just take the discriminant very quickly and find that b squared minus 4ac would be 3 squared minus 4 times 1 times 8, which is 9 minus 32, which is going to be 32 minus 9 is 22, but it's not the way it says negative 23. If your discriminant is negative, you're going to have 2 complex solutions, meaning imaginary. Complex means they have a real and imaginary components. These are complex numbers. They have a real and they have imaginary. So this quadratic will only have complex solutions. So that is the way to do this without actually graphing. But anyway, graphing is the fastest way to do this, as you can tell. Woo! Very good. I'm liking this this Desmos situation. We can put whatever we want up here. It's very professional and stuff. Okay, so that took a while, and I am sorry, but I hope that all of that makes sense. We tried to cover a lot of bases. So a better nickname. LOL what? You asked without a calculator. I now see that. And the graphing is not possible if you don't have a calculator. So the first part of that, I guess, did not really help. However, you should get a calculator. That is one way you can approach this, is get one. Get a graphing calculator. Rent one from a friend. I don't know. It's very expensive. It's annoying, I know. Find one you just use and then give back or something. Or find a used one on the list of Craig. I don't know. Maybe on the Facebook Marketplace? Maybe it's a farmer's market? Some farmers farm calculators. People have a calculator garden sometimes. They grow calculators. But anyway, yeah, you could take out the factor and then figure it out. Beep, 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 beep. Thank you. Yeah, better nickname. Here's a moment you died. That is not good. Why did you die? Don't die. Levi, my accent is traveling all over the world.
Oh, yeah, it is.
Yeah.
The world?
All over the world, yeah. I will now turn this off. So I will clean this. Ooh, mine back. Cosmopolitan accent. Yeah. You bring it out at parties. Not at parties, at parties. When there are other people there. Not at the party. You know what I'm trying to say. My accent makes it difficult to explain. But bring out the accent and everyone will be able to relate to you. Because you are cosmopolitan. You're from around the world. You don't have a home country to go back to. It's very sad. You are a German doctor without a country. That sounds like a Pokemon. I choose you, German doctor without a country. And then you throw the Pokeball. Dr. Levi,
Yeah.
what are your thoughts on that?
I think much on that.
You think much of that?
Yeah.
Yeah.
Okay. Oh, I think it's my turn. What do you say?
I think it is your turn as well. Do you want to erase?
Yeah.
Okay.
I'm also very tired of this accent. And I'm sure everybody else on the planet is too.
Are we going to keep the coats on?
I don't know. I think not. Hey. Questions. Questions. Answers. Community.
Where's the tumor? Where is it? I gotta cut it out. The tumor. If I push here, does it hurt? It hurts a lot. Okay. That's where the tumor is. I'm gonna have to cut it out. Here. Grab onto this stick. Put it, just bite on this stick. And we're gonna cut your leg off. Oh. The tumor was somewhere else.
All right. Let's ask some more questions.
Hey, where's the tumor?
No.
Alright.
That voice makes me so physically uncomfortable.
Where's the German? Ja. I can try to put them together. Wer ist der Tumor?
That's very good, Bird.
These sleeves are too big.
They're like a bat things.
Oh!
Ow.
Mine apologies.
Thank goodness for that, for all of you, right? Because imagine if that hadn't happened and you hadn't seen that. All right. These coats were a hit, dude.
You think so?
Oh, yeah.
I mean, our viewership is just skyrocketed.
Skyrocketing.
Like
yeah.
a skyrocket.
Yeah. In the ways that skies rocket.
Like a rocket in the sky.
Better nickname. You got any more questions? You're the only one today to ask questions.
We should probably just post stuff on Instagram and wait for the eyes and then stream. Such as us.
I'm going to also start recording.
Wow.
And then maybe we can like do a question.
Do we have one?
We can just do a random question. Doesn't matter.
Who's the question?
Hey, you guys got to ask questions or we're going to do our own, which is boring.
Yeah, you don't want that. It's bad.
Very bad for your lungs.
It's
Mainly.
very bad definition of not good. Where's your lab coat?
On the chair.
Just end the stream early. Here in the moment.
No, we don't want to do that, but we want you to answer our request. Fulfill our request.
Yeah. You ever been forced to ask questions here in the moment? Anything in math that you've just never understood? Maybe something in some other subject? I had a student today ask me about light years. She's like, I've never understood them. And I'm like, we're talking about light years.
Nice. Did
And it
you
was
say
awesome.
what they were?
No, I just wanted to confuse her more.
Okay.
I
Is
was
it
like,
the age of light?
It's a time.
It's the age of light.
It's a unit of time. Will I ever find love? Yes, here in the moment. You're just looking in the wrong place.
Yep. Don't look on this stream.
Well,
We're just hollow, empty shells of people.
that are, bruh.
Nah, you will. Don't worry.
Here in the moment, you're gonna find it.
The fun thing about love, let us tell you,
Oh.
since we're very worldly.
Whoa! This is my worldly face.
Seeing the world.
We've had a lot of experience in this world. And let me tell you something. Levi, go ahead and tell him.
Oh yeah, you gotta give love to get love.
Yep.
And by giving it,
That's why I go every day to the blood bank. I give a little bit of blood, and then I get some blood back. Because you gotta
Yes.
give blood to get blood.
yes, it's very much like what Brady said, but less bloody.
Yeah, I mean, the blood they give me is my own blood.
Yeah.
Yeah, they just give it back.
Blood?
Blood.
Blood.
I died, resurrected, then died again, thank you. So you're currently dead.
Just so you know, resurrected can't really be reflexive like that. So you resurrected something. It's an intransitive verb or transitive verb. I always,
Really?
yeah, you don't resurrect. Like,
You can't resurrect yourself?
no, like the zombie does not resurrect.
Oh.
You resurrect the zombie with your
Potion.
the thing you do to them.
Post word.
Yeah, your post word.
That's
You
a good one.
resurrected your soul. Very nice. Oh, what? Ow.
Sorry.
Show them your move.
What's my move?
Show them.
Oh. They really can't see it, can they? My legs are moving, but my jacket looks huge. This looks like I got one of those, the big suit. Look at this.
All right, let's do.
Is this the
I'm
move?
gonna look for an ACT question. ACT. We're not doing hot. We're doing new.
We're doing, what's today, Wednesday? Today's Thursday?
Yeah, baby.
Today's Thursday. Oh man, that's why we have so many viewers, because the test is coming up.
Oh yeah.
The cram sesh.
Cram sesh.
Cram sesh. Put on your cram sesh today.
For you.
and me. Key change, cram sesh. Put on your cram
Pi darkness? PSI? I don't even know what this says.
What are some
Formulas.
important formulas to know for
To know
ACT?
for the AC. Let's do a little rapid fire type of sitch.
Very good. All right. Slope, dist, midpoint.
Wait, actually, we were just talking about the calculator things. Is that linked down below?
Yeah.
Okay. Do you have a TI 84 or 89?
No 89s. They're not allowed. Pi, PSI. PSI. Yeah, do you have a TI 83? I was going to say PSI 83. TI 83 or TI 84 or a TI 84 plus CE? Because we could just give you all of the formulas on your calculator.
And then you have them there. Here in the moment, it was for me, it was also the only school I applied to.
So you got in early.
Yeah.
Because you were bozo.
And then I was done.
Here in the moment, it was also my top choice. PSI darkness. Darkness. Okay, here's what you're going to want to do. They're going to have to go to Twitch, aren't they?
Yes.
So PSI darkness, we got a couple of steps you're going to have to take here. You're going to have to go find us on Twitch, www.twitch.tv/nerdish. And we will wait for you fondly. Can you wait for someone fondly?
Yes.
We'll wait for
That's
you
actually
fondly.
the only way we can wait.
Fondly.
Yes.
Fondly.
We wait very fondly.
Okay, let us know when you're there, and we'll see that your icon will change because you'll be on Twitch.
Well, you might not be able to comment, which is fine, but also open up on Twitch, and then down below the video that's live, we have a link.
To a Discord.
Oh, it's on Discord? Oh, we should put it in the panels.
No.
Yes.
No.
Yes.
Levi, we disagreed on things before, but I'm not going to give up on this one. Also, a question about Stanford. Also, an answer about Stanford. Stanford was founded in 1891 by Leland Stanford
96.
Sr. and his
96,
wife.
96.
1891. 1891.
I thought the dead son
You are
founded it.
terrible with dates.
I thought...
It's 1891.
Okay.
I know that schools like Stanford and MIT continue to be on par with the Is there a term for these schools? No.
The Ivy League is not... It's become a term of endearment for those schools. It's not really that. But it was a sports league. It still is a sports league. That's where it's from. So it was just those schools. Those are some of the oldest schools in the country.
Yes, they're probably.
Stanford is not one of those. Isn't MIT an Ivy League?
No.
Oh.
No, I think, are there 7 of them?
They are in a particular... I mean, Stanford is in the Pac-12, which is a
Pacific.
sports conference. It's a league where they play sport. It's not an actual... it doesn't exist, really. Nothing really exists.
Let's see if we can name
If you don't
them.
think about it.
So there we got Harvard, Princeton, Yale, Cornell, Brown, Penn,
Mm-hmm. Dartmouth.
Dartmouth. There's 7 of them, right?
I thought there were 8.
You want to look it up?
No.
Why?
I just don't care.
You don't care. What about all the caring?
Oh. Yeah, I don't.
Oh.
Yeah.
What did we forget? There's only 7 of them. There's only 7 of them. Ah, that's right.
They are... What do you mean by league? Very specifically, they are in a sports league together.
Columbia.
Columbia. Crack it.
It's a little rough. Ah! PSI. You have now entered phase 2 of your trip to get the calculator programs of your dreams.
Okay.
Next, go down. We understand. Next, go down to our Discord, which is linked below. Enter the Discord at your own risk. Ooh. There's a channel on the Discord that is for calculator programs. It will have instructions and links to the programs. MIT? MIT is not an Ivy League. I don't think it is. I don't think MIT is an Ivy. It's not. They didn't have an institute of technology. They didn't have technology back then.
Right.
Yeah.
Nor institutes.
Like in the UK, I'm sure we have other university associations other than the Russell Group.
Yeah.
The Russell Group is a consulting group.
Where they rustle up some grubs. The grubs are slimy or crunchy. Eaten by a warthog or a meerkat.
Oh. Do not say my name. Hello.
Hello,
Oh.
do not say my name.
You're welcome, Alan Choco. You've got this. Now stop watching us and be free. No, keep watching us. It'll increase our our status on Twitch to eventually become an affiliate so we can sell advertisements to you.
Yes, that's what we want. We want to give you advertisements.
Yay.
We actually don't. I have no interest in advertising. Ever. I'll never do it, I swear.
Also, just joined as someone calling someone a yes. By the way, I think you made a mistake in the trig section yesterday, Brady. Oh, yeah? What was that? I probably did. What did I say? What did I say? I didn't mean it. Hypotenuse on a triangle is 10
You
units.
had the hypotenuse on a triangle is 10 units. Yes.
One size is 5 units.
Okay.
Voice
down,
yeah,
please.
I think it was a 30, 60, 90. Was either 5 or 3. Oh, no. 5 root 3. Not 5 or 3. 5 root 3.
Wait, so did you tell Alan Shogo to find the calculator program? Did you explain
did, yes.
that?
I
Okay,
did,
great.
yes.
Very good.
All right, well, Slayer Darth. It's not. It's 5 root 3. I mean, I think you probably already heard me at this point, but you already had that to go.
Very good.
Yeah.
Okay, so what was we have? Go over probability. Okay.
Levi, what are the chances that you and I are going to go over probability right now?
High.
Very high.
Very, very
You know what's
high.
interesting? When they say that there's a 50% chance of rain, they are the most unsure. Like, you think that 100% of rain, 100% sure about rain is you're confident. 0% chance of rain is you're confident. 50% means they're so not confident. It can go either way,
Yeah.
which is interesting. I just always thought of it in terms of 0 to 100. 100's rain.
Yeah, but the likelihood of rain is 50%.
Right. That's the thing. So that is the least confident you could be.
Yes, but it's more helpful than anything else. I want to slap you
Why?
with knowledge. This would be knowledge, and I want to hit your
They're
ignorant
the
face.
least confident.
The fewest confident.
Oh, jeez.
Probability. Let's do it.
Wait a second. Alan Shoko, I didn't make a mistake. I didn't say 5. It was 5 root 3, the Crimson Chin. The Crimson Chin. That's a good reference. It's been a while. I mean, I can make a mistake. That's fine. But, Alan Shoko, call me out on my mistake. It's probably what you thought Slayer Dark was saying. Maybe.
What about probability?
All of it.
Are we talking all of probability? Where do we even start?
Where we start? Well, we got to start with or and. That's where it always starts.
Yeah. If I can someone find one, a probability question in the tests down below? We could pick one out and do that one.
Oh, that'd be kind of fun.
That'd
be fun. Yeah, what do you think about that, huh? What do you think about that?
quite a lot.
Yes. Probability of rolling a 1 is 1/6. Because happiness is a warm gun. Bang, bang, shoo, shoo. Because the general form for probability is desired over total. I combined my E with my D there. There we go. Okay. There is one side we desire. It is the one side. And there are 6 equally likely sides. So we say it's one side out of 6 sides. Probability of any other one. Maybe it's probability of 3. Will also be the 1/6. Now let's get into some fun stuff. Probability of 1 or 3. Getting a 1 or getting a 3. Those are 2 out of 6. Because in cases of or, you add the 2 probabilities together. Probability of 1 plus probability of 3. All right, which is, again, 1/6 plus 1/6. So for or, you add. Wait, this isn't probability. This is probability. Oh, I mean that number right there. How many 5-digit numbers are there that do not contain the same digit 3 times? That's interesting. That's interesting. That do not. Okay. Oh, that sounds like fun. Alan Shogo, that's a great question. I'm going to do this last thing here. And it's definitely not going to be on the ACT. Then there is this thing. The probability, this marker's not great. Probability of getting a 1 and then a 3. These are two separate events. Probability of getting 1 first and then a 3 next. Two separate events. This is an AND, all right? You're going to multiply the probabilities together. Probability of 1 times probability of 3. 1/6 times 1/6 is equal to 1 over 36.
Turning, you didn't answer the question. You failed the Turing test. I am a senior. Ha! The Turing test. Love that test. Levi's failed the Turing test a couple of times, actually.
I was the Turing test for a couple of years, actually.
Levi was the Turing test. So there's a lot of specific cases with probability. But if it's two different events, same event, a couple different options. Probability of 1 or 3, you add those together. If it's and, you multiply. So what are the probabilities of what's the probability of grabbing a red marble and then getting a green marble without replacement? Those are two separate events. So probability of red times the probability of green, depending on the replacement situation. Alan Shoko, I like this question a lot. How many 5 digits are there? This is counting. Counting and probability do have a lot in common. So it is in the same realm of things. How many 5-digit numbers are there that do not contain the same digit 3 times? Okay, think about this for a sec. So we can either figure out how many total 5-digit numbers there are, and then subtract the ones that do contain the same digit 3 times, or we could find the ones. Yeah, that's probably gonna be the best way to do it. Okay, so first I'm gonna figure out how many different 5-digit numbers there are. Okay, this first one cannot be 0. If the first number is 0, you wouldn't even count it. It'd be a 4-digit number. So there are 9 options for this first slot, 1 through 9. All the other ones could also be 0. So there are 10 options for the rest of them. All right. This is the slot method. You got the number of options in each slot, and you end up just multiplying. So here we have 9 times 10 to the 4th possibilities, which is going to be 9 with 4 zeros after it. 90,000 5-digit numbers. Okay. So in order to find the number of those numbers that do not contain the same digit 3 times, I'm going to find the number of numbers that do contain the same digit 3 times. And then we're going to figure out, we're going to take them away and see what's left from 90,000. Okay, interesting. So here's what I'm thinking. If you have the same digit 3 times, you either have the same digit in this place, you have it here, or you have it at the end, which would be x like that. Okay. Alan Shoko, where'd you go? Alan Shoko, are you still around? Because if you're interested in where this question's going, you should probably stay around. You just stick around after our commercial break. Cue the commercial break. So what are the chances that we get 3 numbers that are the same in a row? Like maybe a 3 and a 3 and a 3. Well, that specific situation, a 3 times a 3 times a 3, would be 1 out of 10 times 1 out of 10 times 1 out of 10. Oh, but then there's this scenario we can't have this being 0. So if it was, you're good. Okay, good. If it was these first 3, we cannot have zeros here. So this is either going to happen for these 3 being 1s, or 2s, or 3s. I don't know if I should be writing all these. 5s, 6s, 7s, 8s, and 9s. The chances of any one of those things happening, like getting a 1 3 times, would be 1 out of 10 times 1 out of 10 times 1 out of 10, because there are 10 digits to choose from, and the chances of getting a 1, except you wouldn't have a 0 here. So you only can choose from 1 through 9 for each of these. So it's actually going to be 1 out of 9 times 1 out of 9 times 1 out of 9, just for the one option. Oh my gosh. Okay. Okay, so for the one, there are a lot of different, Alan Choco, there's a lot of different special cases that I have to consider in order to do this. Does anyone else have any questions? I mean, Levi, what do you want me to do here? I can figure this out. It's going to take
I would say don't do it.
Yeah. You can see where this is going, though. You got to figure out all the different permutations and all that stuff. And, you know, if these three numbers are the same, these two cannot be the same. So you have to find the probability of these two not being these numbers. And eventually you're going to get all the numbers together that have 3 digits in a row, and you're going to subtract that away from 90,000. Yeah, I'm going to stop there. But I am interested in doing that. I might just do that after the stream. Math is doo-doo, yeah. Math is not doo-doo. If anything, math is don't. Think about that. Think about that. Put that in your pipe and smoke it. Don't do that. Nobody should be smoking anything out of pipes or anything. Any tips for the science section? Actually, Levi, didn't you just give away your last tip yesterday for the science section?
Yes, we don't have any left.
Yeah, we don't have any tips left. We actually gave them all away. Everybody gets one, and we had a finite number of tips. I'm going to print the practice test tomorrow. Alan Choco, that's a great idea. You should do that. And you can ask us specific questions. Yes, Alan. Alan, have you taken a test before? Have you done the science section? What do you usually do? There is a strategy to it. I just want to know how it's gone for you in the past, if you have a past. Maybe you just vaporized into existence, and thus vaporized would probably be not the best word to use for that. I don't know, appeared. But maybe you have a past. You know, Levi, there's this idea that the past isn't real. We were just created in this specific moment with memory of a past. Isn't that scary? We wouldn't know the difference. Sometimes I think you don't listen to me, my lord.
Me, my lord?
No, the guy behind you. I have. How did it go? Did you run out of time? Were you like, what is this? What were you like? That's my question, Alan. What'd you think? Did you like it? Did you dislike it? Did it ruffle up your feathers a little bit? Did it squeegee your socks a little bit? That's never been said. I don't think those words have ever been said in that order before. I hate when I can't find the info sometimes. Everybody hates that. Like it doesn't exist. Yes. All right, Alan. So, most of the questions, the information is somewhere in there. Some of the questions, however, it's not. Some of the questions are very difficult. They're curveballs that ask you for a little bit of previous science knowledge. And there's not much you can do about those. There's a couple of basic science concepts that you should know for sure. And then there's some that might show up, like kinetic and potential energy on physics. And they'll give you probably a little definition, but like if you have the experience of doing those in physics, it's going to be a lot easier. There is a question about what are the subunits of proteins, and you'd have to know they're amino acids. It doesn't say that in the paper. You guys are running out of time. Awesome. All right, Alan. We're going to pull up a science section here. We're going to talk. We're going to talk big time. Big time talk. Levi, the section you have pulled up is one we can use, right?
The section I have pulled up.
Oh, is this 10?
Yes, you can.
Are you sure?
Yeah. The 72C. That's the link I followed.
Okay.
Yeah.
Okay. All right, let's find a good one here. All right, yeah, this is a good one.
All right, Alan. Alan. What you should not do is read the passage. I know that sounds weird. I know it does. Trust me. I know it sounds weird. Don't do it. You're only going to need to do it if certain questions guide you to doing that, okay? We got a passage. We got a graph. Great. Go to the questions first. Let's see what happens here. Oh, there's another graph. Awesome. All right, first question. According to figure 2, the solar radiation intensity 8,000 years ago was closest to which of the following? Apparently, we have to go to figure 2. I'm not happy about it. I'll go there. Jeez. Figure 2, right up here. Good, we can see it, okay? The solar radiation intensity 8,000 years ago was closest to which of the following? Quick glance on figure 2. Let's see what we have. We've got thousands of years ago on the x-axis. We've got two different y-axes, which is interesting because there are two different lines. Solar radiation is apparently the dotted line. And then we have CH4 concentration, which is this solid line. And the thing that they're asking us about is solar radiation intensity 8,000 years ago. So let's go to 8,000 years ago. So we got 5, 6, 7, that's 8,000 years ago right there. And then we're looking at the solar radiation intensity. They're both pretty much at the same point, but the y-axis matters because they only put solar radiation intensity on the left side. So right here, it looks like it's around 500. I look down here, there's one that is about 500. And how good do I feel about that? Pretty good. Yeah, 500. So just like that, I've done that question and I didn't have to read anything. Nothing. Pretty wild, if you ask me. If you don't ask me, it's not going to be pretty wild. Number 16. According to figure 2, if the trend in the CH4 concentration had continued to match the trend in the solar radiation intensity, the CH4 concentration at present would most likely be what? Figure 2, same thing. We see that the CH4 just decouples from the solar radiation and goes on its own merry way, but it's asking if it had not done that, if it had continued to match in the trend, where would it be today, in the present? So the present is right here. So these things would just continue together. We'd get right down here. And this right here, this point, we want to look at the right y-axis, which is this concentration one. Looks like it's around 450. So less than 550 is the only thing that includes 450. That's it right there. All right? Still haven't even looked up at this. None of this stuff. Ugh. It's crazy. This guy's out of his mind. 17. Suppose that whenever the CH4 concentration increases, a corresponding immediate increase in average global temperatures occurs. So more CH4, it's going to get hotter. Cool. And whenever the CH4 concentration decreases, a corresponding immediate decrease in average global temperatures occurs. All right, pretty direct link if you ask me. Based on figure 2, another figure 2. Geez. Which of the following graphs best represents a plot of average global temperatures over the past 11,000 years? All right. 11,000 years is what this graph shows us, so we don't have to really worry about that. It's asking us to consider CH4. When CH4 goes up, so does temperature. When CH4 goes down, so does temperature. So CH4 in the past 11,000 years looks like it goes down and then it goes back up again. So we want to pick one where the temperature goes down and goes back up again, and B is the only one that does that. Fair enough. I don't know. Based on figure 1. Finally, figure 1. Thought we'd never get to it. I was angry. Based on figure 1, the average solar radiation intensity over the past 250,000 years was close to which of the following? Okay, figure 1, let's see what we got. Thousands of years ago on the bottom, we got two lines again. Solar radiation, dotted line. If you want to measure that, you look to the left y-axis. CH4 concentration, solid line, we look to the right y-axis to measure that. Okay. Average solar radiation intensity over the past 250,000 was close to which of the following? So solar radiation intensity is the dotted line. So the average of the dotted line. That's the hard part. It's going up and down. It's crazy. It's like a sine curve. Something like this. It's changing in amplitude, but the average is going to be right in the middle. If you had to draw a line, just a horizontal line, that went through the middle of this data, where would you put it? It probably right through here. You're going kind of halfway between your troughs and your crests, which is like right around here. And that gets you to around 480. It looks like it. Probably right in the middle of the graph, maybe a little higher. I don't know, 480-ish. And hey, there's one that's right there, 480. They won't give you numbers where your eyeballs have to be really, really good at figuring out which number is right. Because 520 is just too high. It's just too high. Same with 440 is
Yeah, just too low. So 480 goes right through the middle of the data. That's going to be it. One solar radiation cycle is the time between a maximum in the solar radiation intensity and the next maximum. According to figure 1, the average length of a solar radiation cycle during the past, whatever. So the length between the maximums. So like, let's see, from this maximum here to that maximum there, it looks like it's right in the middle of those bars. We jump to this middle and we jump to that middle. So we've gone over 2 full bar lengths. Each bar, let's see what each bar is. That's 0, that's 50, 10, 20, 30, 40. Yes, each bar represents 10 thousands of years ago. So we went over 2 bars. It's around 20,000 years ago. And let's see, between 15 and 35, that's where 20 goes. Great. Which of the following statements best describes the primary effect of CH4 on Earth's climate? Well, CH4, Earth's climate. Do we see anything here? Well, all we really know is from what they said up here. Let's see what we have here. CH4 gives off visible light to space, cooling Earth's climate. CH4 gives ultraviolet. This is one where the graphs do not give us the answer. So you might have to look at the previous information to see what's going on. So real quick, let's see. Greenhouse gases such as methane, CH4 warm Earth's climate. Great. All right. So CH4 warms the climate. The concentration, does it say anything about how it does that? No, it doesn't. No, it does not. So somehow it warms Earth's climate. There's a couple of things we can eliminate, though, because then they're just patently wrong. Cooling Earth's climate for F, that can't be it. Does not cool Earth's climate. We got warming. All right, that's better. Cooling Earth's climate, again, is not right. So F and H are out of there. So we have G and J still. All right, CH4 gives off ultraviolet radiation to space, warming Earth's climate, and CH4 absorbs heat that comes up from the Earth's surface, warming Earth's climate. If you know a little bit about what they mean by the greenhouse effect, this is going to be easier for you. CH4 is a gas. It does not give off radiation to space. And if you did, you would be losing energy. So the idea of it somehow warming up the Earth, if it was sending radiation out to space, doesn't make any sense. It is J. It absorbs heat coming up from Earth's surface, which keeps the climate warm, or warmer than it, was going to be anyway. This is a typical passage. It's got some graphs, it's got some data, it's got some questions. Okay, most of the passages are going to look like that, except for this one. Hypothesis 1, hypothesis 2, hypothesis 3. This is called the conflicting viewpoint section. It takes the most amount of time because the greatest amount of time. Greatest? Most amount of time? Are those both fine?
Yeah, both fine.
All right. Because you have to read. The other ones you shouldn't read first. This one you're going to have to read a significant portion of this. Do this one last. It's another tip. Do this one last. It's going to take you longer. So skip it. This is passage 2. It's going to be randomly thrown in there. You're not going to know which passage it is, but right now you would have done passage 1. Oh, this is the complete viewpoints one. I'm going to skip that one. And then you're going to go 3 and 4. You're going to finish all of that stuff. And then once you're done with all that, then you come back and do, you got one more passage. Then you come back and do conflicting viewpoints. Okay? So far we've got, don't read the passages, just go straight to the questions. You will need to go to parts in the passage sometimes. You will. There are times where there's a word, you don't know what it means. And they're not counting on you knowing what it means. They are going to have a definition for you, which is going to make everything else click into place. So, not saying you're never going to read it. I'm just saying let the questions define when you do that. But yes, you want to do the conflicting viewpoints last. You want to do that last. The rest of them are going to be a little bit quicker. What is that? But that's the basic premise behind the science section. You need to try this out before you take it this Saturday. So, print one out, do it. If you want to put a timer on for each passage, then there are different numbers of questions per passage. There's 5-question passages, 6-question passages, and 7-question passages. A 5-question passage should take you, what is it? It's like 4, hold on. Because if you work at the right pace for each question, or each passage, then you won't have to not know which one took you way too long. Wait, 4 divided by 40. No. Yes, 0.1. Sorry, 5 divided by 40 times 35. Okay, so 4 3/8. Minus 4. I always have to do this. 425. 6 divided by 40 times 35. 515. 6:05. Put these amounts of time on a timer and do each passage one at a time using that method. And this is approximately how long it should take you to finish each passage, depending on the number of questions in them. But you've got to build up a sense of pacing about how fast you have to move through this thing. And that's really the only way you can do it. That's the only way how. All right, Levi, I've been up here long enough.
What do you want me to do?
I don't know, ask them.
What do you want me to do about you being up there all the time?
Oh, I don't know, ask them.
All right.
Do you have a child?
I do.
I also do.
Oh boy.
Got
What
it,
else you
Supervisor?
got, Alan Choco? Alan's been on here before. I remember the name.
Don't forget the name.
And 70% reason to remember the name.
Trust me, Alan's gonna be huge.
Yeah? Ow. What? You shocked me.
I didn't mean to.
It's my first shock of the season. Don't blow on. Ow. What? Come on.
Sorry.
I don't know if you guys could see the fuzzy. Will you be live tomorrow? Yes, Alan, we will be.
Will you?
Alan, you taking the test tomorrow, I assume? You should definitely do a bunch of practice, come back and ask us questions. Ideally on the tests that are down below. The ones higher up in our list are the more recent ones. You should do those. Ask us questions on those. We can pull them up. Other stuff, if you get other stuff illegally, we can't pull those up because then we get in trouble. Which is valid, but annoying. But valid.
It's valid.
It's valid, but annoying.
Wow. You haven't done it in a while. It
I
sounds pretty
think.
good.
The thing is when you're exposed to
The radiation,
the radiation.
you become huge, green, strong. You don't know what's going on until you come to. And then there you go. Your best friend's there. His head in a different corner of the room. What'd you do? That was your best friend. Good luck trying to befriend a head.
Where's that from?
I made it up.
When?
When?
Yeah.
I stayed up really late last night thinking about what I was going to say as
Oh,
well
okay.
today.
That's good. But I kind of just guessed. Someone on Reddit posted, I got the right answer, but I kind of just guessed with education.
Educated guesses?
Yeah, I guessed with education. How can I rationalize this answer? Hey Brady, the most recent post on the ACT Reddit, can you link us to it? I'm pretty this dude.
Why?
By using the rule that the sum of the paired numbers is a perfect square. Okay, so we have the numbers 1 through 18, so I'm going to write them all up. 5, 6, 7, 8, 9, 10, and we have to add, we're going to pair up these numbers. Maybe you've seen this question before. We have to pair up these numbers in a way that the pairs add, the sum of each pair adds up to a perfect square.
Maybe
So,
like,
yeah,
can we do this question?
I'm not writing it up here, so, I mean, like, it's fine. Unless you really don't want to.
No, keep going.
Okay. So we have to pair off these numbers so each sum is a perfect square. For example, if we take 5 and 14 as a pair, that wouldn't work because that equals 19, which is not a perfect square. But if we wanted to do, let's say, 1 and 3, that equals 4, that is a perfect square. There are 18 numbers, so you're going to have 9 squares. Yeah, go for doing that one. But, Alan, just so you know, that is not a legally released ACT, so we can't do that one on here. Or we can, you know, if you ask us a question based on a concept, we can do it. The science section, there's not much we can help you with. So ideally do one of the ones down below in the panels on Twitch. We can pull those up and show you them, and it's a little bit more useful. But you could also do both. Okay, so this is what we're going for. Pairs of numbers that add up to perfect squares. Now, this question, you have to brute force it. There is no other way to do this. I think, what is the question actually going to be? Okay, so what number is paired? The question is, what number is paired with 1? That's the question. What number is paired with 1? So eventually we need to get 1 to go with some other number. Now we can't just say, okay, let's make 1 go with 15 because 1 plus 15 is 16. We're done. That's an okay guess. Now let's think about what all the possibilities 1 could go with, right? It can't go with 2 because 1 plus 2 is 3, and that's not a perfect square. So we could have 1 with 3. We could have 1 and 3. We could have 1 and... What are the perfect squares? Actually, let's write that. That's going to be very helpful. Perfect squares are 1, 4, 9, 16, 25, and 36. And let's do one more, which would be 49. Now, some of these are totally impossible. 1 we can't do in these pairs. So this is not going to help us at all, right? Because the smallest number is 1, and we have to pair it with something. There's no 0, so we can't do 1. Now, same thing goes with the 49 and the 36. Because 18 is the biggest number, we would need another 18 to get to 36. So no pair of these numbers can sum to 36. So that means that 36 and 49 are out. The only numbers we care about are these 4. These are the only 4 possible perfect squares we have that these need to add to. Now, we need to go through this as logically as possible because this can be an extremely time-consuming problem. Even doing it the most efficient way possible, it's still very time-consuming. If you see something like this, skip something like this. Go on to other stuff. This is a very time-consuming problem. You can figure it out. And there is a way to figure it out without guessing. So that's what we're going to do. Now, we need to think about the best approach to this. There are a couple things. We know that the numbers at the top, so 18's got to have a pair. And it can't add up to 4, 9, or 16 because it's bigger than all of those already. So that means that 18 must go with 7. 18 and 7 have to go together, so they're out. You linked it? Okay. So this is the approach we're taking. That's not a guess. We know that. We're trying to use our logical process of elimination to get through this. Now, same thing goes with 17 and with 16, because 17 and 16 are greater than or equal to 16, so they have to go to the 25. So 16 and 17 go with 8 and 9. So now all of those numbers are out. We have 1 through 6. We have 10 through 15. Now, I don't think... Oh, we could still add up to 25, so that's a bit of a bummer. Now, what can go to 4? We don't, and now none of these are absolutely necessary. So let's think about other stuff. Can we get... All right, what is the best approach here? 15 can go to 16 or 25. So that's, we can't know for sure. 14 can go to, or let's do it this way. 15 can be paired with 1. It can also be paired with 10, right? Because 1 gets it to 16, 10 gets it to 25. 14 can be paired with 2, and it can be paired with 11. So that's also fine. 13 can be, and now we can't get anywhere with those, and I don't want to guess this early on. 13 can go with 3 to get to 16, or it can go with 12. 12 can go with 4 or with 13. 11 can go with... Maybe I want to try 10.
5 or 14.
No, it doesn't work. So 11 can go with 5 or 14. 10 can go with 6 and 15. And I think we just keep moving through like that. So I'm going to write the other ones up top. I guess I do have room. Also, if anybody has any questions, please ask me, because this is difficult. 6. Now 6 can go to 9 as well. So this is going to start getting a little messier now. So 6 can go with 3, 10, and 19. Okay, it can't go with 19. So now 6 and up, or 6 and down, can't go to 25 anymore. So we don't have to worry about that. So 6 can go with 3 and 10. Is this on the board? Yeah. 3 and 10. 5 can go with 4 and 11. 4 can go with 5 and 12. 3 can go with 3 can go with 3 different things. It can go with 6, 13. No, sorry. 3 can go with 1, 6, and 13. Room 1, 6, 13. 2. This is harder than I thought. Oh, 2 cannot go to 4 because there's no other 2. It can go to 9 with a 7. No, there's no 7, so it can't go to 9. 2 can go to 16 with a 14.
Here it goes.
So there we go. I started on the wrong end. This took too long. But 2 goes with 14. It's already done. So 2 is gone and 14 is gone. Now, 11. Now this is the waterfall starts. 14 can no longer go with 11, so 11 has to go with 5. 11 is with 5. So now we need to cross out all the 5s and the 11. So now we have, well, 14 we already knew. So there's that. 2 is gone. Oh, yeah, that one's gone too. Let's see. We still have 3, 4. We have 6. 1 at the moment can go with 3. It can go with 8. It can't go with 8. And it can go with 15. So it's got to be 3 and 15. Okay, I'm just going to...
You're good. You crossed out. So now 4.
So now we have 4.
You didn't cross out the 5.
Oh, we didn't cross out the 5. That's what I was looking for. Okay. So now the 4 can go away with the 12, because that's the only one left for that. So 4 and 12. Now let's cross out all the other 12s. This is a 12. So that means that 13 has to go with 3. If 13 goes with 3...
You're done.
Oh, we're done. Well, no.
No, look at the 1.
Okay. So now the 3 is no good, so the 1 has to go with 15, and that's the answer.
Woo!
So that was still very time-consuming, and I took the slower approach going down from the top. I thought the top would help. At the beginning it did, but then I should have started at the beginning. There's not necessarily, you may not make that realization that that's the better way to start. I did not, and it took me too long. And that's because the 2 doesn't go to the 4, and we can't do whatever, and we can't do the 7. So it lost the 2 and the 7. I didn't know, so it took a very long time. That's why I would say skip this problem or this type of problem. If you know something is going to be very time-consuming on the math, don't do it if you often have trouble finishing in time. This is not only a very difficult problem, but a very time-consuming problem. It just is what it is. There is no really good way to do this. I can't. I've done this problem a couple times over the decades, and I'm not sure of I don't know of a faster way to do it. Guessing and checking is not a good call because you still have to work your way through everything anyway, and you start, branching out too many times. Maybe you get really lucky. Hey, I just want to say I got like 200 plus points on my SAT thanks to your guys' cram session. Thanks, my man. Awesome. Congrats on the 200 point increase. That's a huge increase. So are you done, Biscuit? That's awesome. Are you done with the SAT now? You can move on with your life? You could also become a tutor. Yeah, it's college now. College time now. Yeah, it is. Have you written your essays? We should do a giveaway for this on Instagram soon.
Yes.
Yeah.
Yes.
Let's see. We have... Today's the what?
Today is Thursday the 24th.
Okay. I don't know if I want to cram in a session for the early application deadline. Maybe I do. I don't know. You have not begun. Okay. Do you know? Are you applying early, anywhere or no? It's a really difficult question. But a very cool one. What time is it? Ooh. Well, due to money reasons, I'm going to go to community college for 2 years or so. Ah, there you go. Money reasons. Get yourself an internship and work experience as soon as possible. And if you know your field, awesome. If you don't, you are totally out of luck and everything is ruined. But if you do, get yourself work. I think that's one of the really good things about community college is that you have access to your network already of whatever that is. And work experience is something that a lot of people who don't go to community college don't get for a long time. You know, people don't do internships. Make that a priority because it helps you a lot in entering the workforce if you have experience. And then after a while, you know, then you can go to non-community college if that's what you're into. All right, we do need to go. So definitely never spend too much time with Brady because it's just maddening.
What? How do you think I got as weird as I did? I'm with myself literally almost 100% of the time.
Yeah, I'm really sorry about that, man.
Yeah.
We are going to go because we have students to tutor. If you want tutoring, you go to that thing, which is also down below.
Accelerate tutoring.
We'll see you tomorrow.